just for social media and posting. So if you are able to, maybe turn on your videos. So I take the screenshot. You can pose however you want. Want to take a cool screenshot for posting afterwards of this amazing session, and then we're going to introduce Casper and then start. So if you're willing, if you're not willing, also you can keep your camera off. That is also an option. And I am taking the screenshots now. Awesome. Oh, no, I didn't take the picture with Oscar. Okay, I have to repeat now. Okay, there we go. Let's take our screenshot. Cheers. Okay, awesome. I've taken the screenshots. Thank you so much for joining. I'm going to have more people also join. But wanted to just introduce the session. As many of you know me, my name is Rael. I lead builder initiatives here at GoodDollar. And call we have Casper. Casper is a senior software product engineer at Superfluid, and I'm sure he's going to give you a better introduction than I can give you. So I'll let him do that. Yeah, we have collaborated with Superfluid to bring you these interesting workshops on AI agents and money streaming. And I can't wait for Casper to also introduce Superfluid Skill and all the links thereof. So Casper, the floor is yours. Take it away. I'll be just chiming in when you need me. In the meantime, my work will be mostly admin and letting people know.
Thank you, Rael. And thanks to everyone for showing up. My name is Kaspar, and like Rael mentioned, I'm here to talk about Superfluid's money streaming and AI agent-driven development. So without further ado, let me start my presentation. Or wait, let me share my screen first. Sorry, a little bit nervous. I don't present every day.
It happens to most of us.
Yes. Anyway, can you see my screen?
Yes, we can. I can see it.
And can you also see me at the same time, or do you just see my screen?
I can see you. You're standing, I think.
Yeah,
So
I'm
perfect.
standing here. Okay, that's great. So, Superfluid and AI. The goal today is to make you more familiar with the Superfluid protocol and its quite innovative financial primitive. And I really want to talk about AI and how it has shaped the software development industry and how it can be applied when working with Web3 and when interacting with the blockchain. About myself, like Rael mentioned, I'm a software engineer at Superfluid. I've been in the software development industry for over 10 years now. So I've been in the weeds of things for a while now. And 4 of those years I've been with Superfluid. Quick light introduction about myself is that I'm from Estonia, which is this small Baltic country in Europe. This is our flag, and Estonia is here, the red one, between Finland and Latvia. A little bit more about my personal life as well is that I like to play disc golf. That's one of my hobbies. It is like ball golf with the clubs, you know, but instead of balls and clubs, you have frisbees and baskets. All the other rules are the same. Also, before I became a software engineer, I used to be a professional poker player. So the idea of kind of doing something with my mind on the computer and on the internet and using my competitive, I guess, skills to make money was really exciting for me from early on. But since then, I moved on to software engineering, but still in my free time, I'm interested in strategy games and the likes. And here's a few pictures of me doing software development. These are terrible pictures, but yeah, I'm a believer in, I guess, doing software development from a laptop. I believe in having a single station with single screen and single keyboard that I can move around with and to my software development in many places. Okay, so the agenda real quickly: Superfluid protocol, then this new feature we're coming up with, which is clear signing, a brief history of AI-driven engineering, then introducing the agent's skills, and a deep dive into what we're releasing today officially, which is the Superfluid skill. So Superfluid is real-time finance on the blockchain. What does it mean? It is a new financial primitive of making money move, or in the case of blockchain, making tokens move every second. So instead of having discrete transactions, so giving one bill to another, essentially, on the chain. So you make a transfer, you hand over the money or the tokens. Then in case of Superfluid, our main, I guess, flagship feature is to move the money every second. So the money or the tokens move every second, perpetually and continuously, as long as one account has the funds to send them, and the receiving end will receive the tokens every second, and they're able to, if they want, redirect the money coming in to another, I guess, location. So they can use an application with the tokens that are streaming in every second, or they can send it to another person. So here's a slide about the money streaming part. An important, I guess, consideration is that the money moving is settled immediately. So every second that the tokens are transferred, they are settled. So it's not like a loan, it's not allowance that's moving. It's actually the token balance going from one account to another. And you might think that this means a lot of transactions happening. That's not the case. It's just a single transaction, one transaction to start the stream, and the stream will flow on the blockchain as long as you have tokens or as long as you stop the stream. So this is one of the, like I said, the flagship feature of Superfluid, but there are more features. One is programmability of these money streams, and some other features. I will cover them next. So maybe first thing, when people hear about this concept of money moving, money streams, it's a little bit like kind of a mind-blowing experience, in the sense that this is not how we are used to money. This is not how we are used to making transfers. So it is kind of a little bit dissolves the way we think about making transfers. Maybe quickly, I'll show in my browser. So the magical moment with Superfluid is often kind of seeing the money stream for the first time. I quickly jump into our documentation, and this is kind of the magical moment. Oftentimes is that you start your first stream, and then you see you're either receiving the money or you're sending the money. And yeah, this is how it moves. It moves every second, continuously going and going. Back to the presentation. So maybe the next question, after kind of being surprised by the concept, is why? Why do we need this? What's the purpose? This is a new financial primitive. This is enabled thanks to the blockchain. This is enabled thanks to the programmability of Ethereum virtual machine. So there are many use cases. There are many use cases emerging because, again, this is such a new thing. But I guess things of note are doing reward distributions. So distributing tokens to, let's say, your community members. It is possible to invest every second. It is possible to pay salaries every second. It is possible to pay for like an API access or some type of a service every second. So there are many use cases. and more use cases are emerging again. This is because it's such a new thing. Blockchain is new, Ethereum is new, Web3 is quite new, and Superfluid, again, is built on these very new emerging technologies. So the core of kind of how Superfluid works is it's a protocol. It is on-chain. It is free to use. It is fully open source, lives on the blockchain, and kind of the entry point into the protocol, into this new financial, let's say, mindset are the super tokens. So any token can have a super token deployed for. So what a super token is a token that can move per second, and to some other things as well with Superfluid. But right now I'm focusing on money streaming for, I guess, easier explanation. Yeah, on the left side, I mentioned wrapper super token. So you can take any existing super token like USDC, I think is a good example, and you can then wrap it into the super token variant. And now you have USDC, we call it X. So that's our kind of a convention. The super token variant has an X at the end. And it is always one-to-one. So you can always wrap, you can always unwrap. But you take this regular ERC20 token, you wrap it into a super token, and now it is still an ERC20 token. It has still has all the features of an ERC20 token, but it is now also possible to do much more. And in addition to wrapper super tokens, it is possible to create super tokens that are super tokens from the get-go. So you deploy a new ERC20 token. So you deploy, let's say, GoodDollar, and it can be, in this case, so $G is already a super token. It doesn't have an underlying wrapper. It doesn't have an underlying ERC20 token. It is inherently super token. So it is immediately, you can use it like a regular ERC, trade it on exchanges, send it, transfer, buy it, whatever. But also it comes immediately with the Superfluid primitives. So this is why this, I guess, presentation is very relevant to the Good Builders season, is that, yeah, $G is in a perfect kind of a situation to take advantage of what we've built with Superfluid. Maybe a little bit of a technical part of Superfluid protocol is that it is kind of a token infrastructure. And what it is modular. So the modules can be added to the protocol. And currently, what I've been describing, the money streams, it is just one module. So as time goes on, we can add more modules to the protocol and kind of expand the capabilities of these tokens and kind of expand the financial primitives. And yeah, currently we have the two main modules, the two main agreements. That's what we call a module, and on the protocol level, it's an agreement. And we have one for constant flow, which means kind of sending a stream from one person, or let's say one account, to another. And it is moving at a constant rate, like I said, as long as it's stopped or until I guess the tokens run out. And we have another module which enables kind of many-to-many, not just one-to-one, but many-to-many token distributions. So instead of sending to one account, you can send to, let's say, 10 accounts at the same time. And you can either do it instantly as like a transfer. So you split, let's say, $10 between 10 accounts. Then if you do it instantly, you can choose how much everyone gets. But if it's, let's say, the shares are equal, then everyone will get $1. And you can also do it streaming. So you can make it stream. Let's say we're streaming every second $1 to 10 receivers, then everyone will get $10 per second. Worth mentioning here is that this is infinitely scalable, and this is fixed gas. So you can create, or let's say you can use GDA, the General Distribution Agreement, is that you can have 10,000 receivers, you can have 100,000 receivers. It doesn't matter how many receivers you have. Every time you distribute through the pool to this module, then the gas cost is constant. So it doesn't go up because of the amount of members in the pool. So you can actually have essentially unlimited amount of members. And what's mentioned here is also it's many-to-many distributions. So that means you can be a single, let's say, account distributing through the GDA, but you can also have many distributors. So many people are streaming, and it gets split between many receivers. So along with the Superfluid protocol, what you get when using it and what GoodDollar can already kind of, let's say, tap into as well is that Superfluid is programmable. It comes with this concept we initially called super apps, but what they are essentially are smart contracts that have callbacks, like they have hooks. So these are programmable. So for example, you have a contract, and every time someone opens a stream to this contract, then this, let's say, the hook logic, the programmable logic of your smart contract will run. And every time the streams get either updated or deleted, anything happens to the streams. If they're manipulated in any way, then your smart contract triggers and can do some logic. So that's how we built tools like, let's say, the DCA investing kind of platform, where you can invest every second to buy a token or sell a token. And based on the, I guess, your streams, let's say we call it flow rate. Based on your stream's flow rate, then the smart contract kind of changes its state and does something depending on how much you are streaming. What's also worth mentioning is that if you have a super token, then what we've enabled very early on with Superfluid protocol are batch calls. So you might know batch calls with account abstraction nowadays. So what a batch call is that if you want to create a stream, for example, then with batch calls, you can have many things happen in the same transaction. So if you want to, let's say, okay, start 10 streams. So now instead of doing 10 transactions with this feature of a batch call on the Superfluid protocol, you can actually have it done in a single transaction. And in the single transaction, you can kind of put together many operations that touch Superfluid. So again, this is maybe something you've been or heard of before or used already with something like a Gnosis safe, which is an account abstraction or like a Basis smart wallet or something like that. So those are batch calls essentially on the level of the account, but what Superfluid enables, and we kind of did it before the account abstraction, is that you can do the batch calls on the level of the token. So you don't have to have a smart account. You can use your regular EOA wallet. So, just the easiest private key-based wallet. And with that, you can already do the batch calls. Transitioning from the batch calls, so you can do many operations at once with Superfluid. Then I guess next frontier. So maybe quick mention is that the batch calls, what they enable is better UX for the user. If you're using Web3 and where account abstraction came to be, it's related to the user experience of interacting with apps and interacting with smart contracts. So this problem of doing big batch transactions is relevant to both the existing account abstraction-based batch transactions and to the current kind of superfluid batch transactions as well, which is the transactions are not that human readable once you start putting in many operations there. The thing that the user's wallet will sign will be kind of a messy blob of zeros and ones and other difficult things to understand. So it kind of ends up being like blind signing. You kind of have to trust that the application you invoke the transaction from did everything correctly and passed the data correctly, and there was no intermediate malicious activity going on, kind of changing what could happen on chain, which could mean obviously the loss of funds. But what the new feature clear signing brings is that similar to the batch calls, now every Superfluid token is able to take advantage of clear signing, which means having like piped data. So you sign a message to be sent to the blockchain, which has very clear human readable information, what is going to happen. So this is an even bigger enhancement to the user experience in a tap. And also, this is something, I guess, in this newer, let's say, age of AI and agents could become very valuable, is that when an agent proposes a transaction to be invoked, then whatever they proposed will be easy to read. So this is just kind of I will move on from this slide. And this is how it kind of looks like. The traditional signing, as you see on the left side, would look, so it's doing two operations, but the main part of the transaction is kind of a messy. And on the right side, we have the clear signing, which means this is what you will be signing in your wallet. This is what you will see. You will see the token, you will see the amount, you will see the flow rate. And what's interesting is that this message can be translated. So depending on what language you have set or you choose, you will see a bit of a different message just to have the kind of the language be to your liking. So this is an upcoming feature. Yeah, and there's a demo website you can go to. Okay, so that kind of concludes my introduction of Superfluid as a protocol. I hope you guys are still with me.
I am still with you.
Cool. So moving on, I want to talk a little bit about AI-driven engineering. Like I said, I've been in software engineering for now over 10 years, and boy, have things changed. So on the left side, I kind of bring out the evolution of my day-to-day work. And for bigger part of those 10 years, the process has been for every developer out there, essentially, that they will use internet to search for questions, for answers. They go to Stack Overflow, they find answers from documentation, and when they're using their developer tools, then the main kind of benefit you get when writing code from the tool is that when you type a block, like a dot, then it will maybe recommend the next function signature or some kind of a function name. So that's it. With the introduction of AI and coding assistance, so we quickly got to the first evolution, which I think came as a really like a big practical shift for developers, which is that AI predicts what you want to write as a whole in the next, let's say, block of your code. So I think a great example was Cursor with their Cursor tab feature. So instead of previously you would write out most of it on your own, but with Cursor, it kind of ends up being that you just go tab, tab. It keeps recommending nice things, quite on-point logic, and you just go tab, 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 and the code, comes out much quicker. And this has been especially useful, I think, when making changes and making like cleanups to the code, so refactoring. So after Cursor Dab, and I guess GitHub Copilot is also worth a mention here. After that, we got to coding agents. So not just in your IDE, you would now have a full agent. So Cloud Code is something I think kind of innovated on this, is that from your terminal or from your IDE, so your development environment, you fire up a coding agent, and with the agent, you kind of make a plan. You ask it to plan out a feature, and coding agent wouldn't just see the one file where it was completing the logic before. Now it could go through your whole code base and come up with multi-file edits. And this process is, you let it analyze, you let it make a plan, you review it, and then if you're happy with it at some point, then you're just like, okay, implement it. And once that's done, then you kind of review it. So it is a very iterative process for the software developer working with the AI. But the part of writing out the code yourself as a developer that I've been doing for the last 10 years, just typing out the code and kind of navigating around the code, then this part has, let's say, the value of this has diminished in the sense that now you kind of work with the AI, and the AI can output a lot of the implementation you had in your mind that you wanted to achieve. It's just that now you don't have to write it out. The AI writes it out. You just kind of work with it. So coding agents are something I've been on for now, and I haven't moved on too much to the next stage, to the next evolution, which is coming up, which is fully autonomous agents. So AI agents kind of working on their own, possibly for hours, and coming up with new features to implement, and essentially getting the human out of the loop even more. So with coding agents, the way I've been working with is that I'm still in the loop all the time. I'm still asking, prompting, reviewing, but with this next shift, which is, you might have heard of it, is OpenClaw and like Ralph Wiggum loops, is that the AI is running in a loop continuously and making changes and coming up with next things to do and testing its own work and things like that. So that's something we're moving towards, and I have a little bit of a bonus at the end, but we'll get to it. But working with AI, working with novel protocols like Superfluid, something that's very new, creates a problem for LLMs, which is that they don't know about let's say, the fine details of the protocol. And they have a lot of like old information in their training data. And kind of in Web3, using AI is actually quite good, because every smart contract you deploy, you get an ABI, which means the application binary interface. So every smart contract deployed already kind of has an interface that the AI can read and interact with. But there are still some problems with it. And in the case of Superfluid and building with Superfluid, is that, yeah, throughout time, we've updated our contracts. We've had patterns. We've had tools come and go. So what's the problem is that the AI is constantly kind of bringing up old things, bringing up old patterns. And yeah, sometimes, as it's called, hallucinating things that are not there. It just kind of does it, writes out some block of code that just is completely non-existent, and I'm not even sure where it came up with it. But there's a solution to that, and I'll get to it next. And also added a disclaimer here quickly that yeah, AI can be very useful when working with Web3, but at the end of the day, you are still responsible for the output. You have to verify it. So the AI is a tool. It's not a senior engineer making the final decisions, you are still the one to make the decisions. So in the evolution of AI, we've got to agentic skills. This is very recent development. And what they are, agentic skill is essentially a little bit of context for your AI. So let's say when I ask a question about Superfluid, currently the AI to find something out would go to the internet and start looking around the internet and kind of Googling like you would maybe use Google. And it will, every time you ask something, it would have forgotten about the previous links. Every new conversation you have, it has forgotten about the previous links it used, and it again starts to Google. And this process is quite inefficient. So what skills achieve is that it is just text essentially, and with some helper scripts, but it is essentially text. It's a small folder, it's a small file. Everyone here probably can create it. It is not difficult to do. And I actually really recommend you try out creating your own skills. It can be for anything. But again, essentially what a skill is, it has a little bit of a front matter for the metadata. So in the case of a Superfluid skill is that this is a knowledge base for Superfluid. So when the user asks a question related to Superfluid, then load this skill. And then once the AI loads it, it gets more instructions and a lot of references to the kind of, let's say, more detailed files or more detailed guidelines. And what this is a lot about is kind of managing the context for your AI. As you know, if you're talking to an AI for a long time, it will build up a lot of context. And the bigger the context is, the less it kind of focuses on what's relevant. It starts to forget things, it starts to make mistakes. So you really want to be efficient with the context. You don't want to overload it. And this is what an agentic skill achieves, is that you can give a lot of information, a lot of context kind of to the AI without actually overloading the AI's internal context. And also you might have heard is that AIs have context limits. So there are also hard limits. So when they hit a certain amount of context, then they will kind of stop working and they need to kind of condense their context. But yeah, agent skill kind of solves it. So the ecosystem for the skills is that it has been adopted, sorry, very quickly. Again, it's pioneered by Claude Anthropic, but it is supported by all the coding agents nowadays. So Cursor, Gemini, OpenCode, etc. And skills are kind of similar to MCP, the Model Context Protocol. You might have heard of it. So MCPs came before skills. And yeah, I think this is something that people currently kind of don't understand. Okay, we had MCP. Why do we need skills? And I think when the MCPs came, then I also ended up using them wrong in a way that I kind of ended up using them as skills. But what an MCP is just kind of an access to a tool, so or a platform. So MCP is for, let's say you want your AI to be able to talk to your GitHub account. You want AI to be able to talk to your, let's say, linear project management board. And MCPs are mostly for kind of managing the API keys for these connections, but they're not for giving just, let's say, context for something informational. And what skills are very simple. It's knowledge. So this is knowledge in a little package, which can be easily shared. And the knowledge can also contain scripts. So previously, a lot of scripts and logic was put into MCPs, but now, if the script doesn't need any authentication, then it can just be a little bit of code in your skill. And generally, skills are lighter weight. And in the context of Web3, in the context of blockchain, the scripts can be about calling certain APIs that are public to use. And it can also be about calling the blockchain nodes for information about smart contracts, about the state they're in right now on chain. I hope that's clear. So with this new development in the AI agent world, we saw the opportunity to create a skill for our protocol. And yeah, why did we build it? Because of the reasons I mentioned previously already, is that yeah, the AIs have known about Superfluid for a while. When ChatGPT first came out, it was a little bit frustrating because the ChatGPT didn't know about Superfluid at all. But after a few, I guess, updates to their training data, they started knowing about Superfluid. And nowadays, you can ask any model about Superfluid, and they will give actually quite detailed answers. But still, to this day, or I mean, it's quite clear why, is that they can't answer about things that are now in the past. We have moved on. We have newer solutions, but the problem is that these newer solutions, newer patterns, are not necessarily in the training data of these AIs, as the older patterns are often longer lived on the internet, which the AI has used for its training. But the newer solutions might be just a single landing page for now. But we know, as kind of the, let's say, the maintainers of the protocol, that this is what you should be using now, but the AI doesn't know it. And when the AI just goes again to start doing web searches, it might not reach to that conclusion. Worth mentioning here is that in Web3, like I said, is that the API is quite a good input for the AI, but the APIs, the contract interfaces, don't tell the full picture. So the APIs lack detail. They have the basic data about what are the input parameter types, what's the function name, and what will the function return. But any function could have a lot of internal details that are not apparent from the API, which is that who can actually call it, when can this function actually be called, what could be the errors that emerge from this smart contract, or what are the events emerging from this smart contract. And yeah, the API doesn't tell the full story for AIs. And the way we build Superfluid Skill is we still rely on the API, but we've converted it into a format which has more context, more detail. So it kind of covers the, let's say, the shortcomings of having just a really plain, let's say, smart contract interface without the nuanced details. So here's a little visual example. It's a very simple example, but yeah, essentially on the left side, you have a function for creating a flow. Yeah, I mean, it is just bare bones. It's a function. This is the name. These are the inputs, and that's the output. But the way the skill is built, so we've kind of built it bottom up. We still see the smart contracts as the king. That's or at the end of the day, that's the most important part that has to work correctly, and that's what you will eventually interact with. Is that this API format is more language model token efficient, so it takes up less context in the brain of the AI, but it also has actually more information. So it has information about who can access it, what events are emitted, what errors could happen, and also human readable notes and gotchas and some instructions. So when the AI goes to call this function, it will immediately see in this localized context everything it kind of needs to know. So it makes better decisions. It makes better, I guess, assumptions about how to interact. What's inside the Superfluid skill? So currently it's kind of a general knowledge base for Superfluid. But yeah, what we have inside are the protocol concepts, the APIs. We have indexing solutions in addition to our SDKs and our apps. So we have subgraphs, which kind of index the blockchain data. So that's more efficient oftentimes to query for your application and for your, I guess, whatever needs. Yeah, and it's constantly growing. But with the skill, the thing is you can grow the knowledge base, but it doesn't necessarily make the AI less efficient with it. It's very incremental how the AI finds the information. So it's like documentation, but it's meant for AIs. And when you're using your AI, it has immediately access to it, and it knows when to invoke it. So here I was planning a pre-recorded demo, but didn't end up doing it. So I will do it live. I will show a bit of a live demo.
That's
Quickly
awesome.
checking. Quickly checking. You still guys are still with me?
I am with you. I think also the reactions on the call that we are with you.
Mm-hmm.
Yes, we are. Yes, we are.
Cool. Yep. So maybe while starting it, then yeah, we have a landing page for the skill now. It is skills.superfluid.org. And when you're using your coding agent, the installation for the skill is just this, actually this one command, npx skills add superfluid-org skills. So that's just one line to add the skill to any coding agent you have on your computer. And what's nice is you can also add it to things like Claude Desktop. And for demo purposes, this is what I will use. Yeah, so if you can see, if I go under this, first of all, this is Claude Desktop. This is the user interface-driven application for using the Claude models. And here is this customize page, and here you can add your own plugins. So you can upload the plugin through the GitHub repository, or just upload it as a zip. And now it is aware of the Superfluid skill. So that means when I use Claude in cowork or code, then it should invoke the skill to find relevant information. Oops. And maybe one thing to start with, which I think is immediately like a cool use case, is with this you can add like scheduled tasks. So let's say I need to come up with something on the spot. Let's say find $2 biggest streams created this month. So this is a automation essentially. Find kind of the same thing, and just in case mention it to use the skill, use Superfluid skill. Find the biggest $2 streams created on Zello network. Yeah, I'm drawing a blank right now, but essentially you can have it to automations here. So I will save it. Here is the automation, and I just click it run, And it will run and think for a while. So I will let it think. It already read the skill and it's doing its business. So maybe next like quick demo example is that I'm in this Claude's cowork view, and let me just ask like a question. Let's say I said words like GDA and CFA. To me, this is like very common terminology. It is what I use every day. And let's say I ask just like, I heard about GDA. What is it? And hopefully, the AI will realize GDA is a concept from Superfluid. It will load the skill and give me a good answer. Yeah, which it did. And this is like actually it is quite detailed answer, but the point here is that this is like a really good way to explore. You can ask really dumb questions here, or very smart ones, or very difficult ones, and the AI, has a good knowledge base to give you good answers. And let's do one more. Visualize GDA versus CFA. I don't know. Talking about visualizations, then just to kind of quickly show from our documentation again is that so GDA is for doing distributions, and yeah, it kind of looks like this: is that one distributor or many distributors, and when they distribute the tokens, it gets split between all of the members of the pool, between all the receivers. And you can do it instantly like this. So this is, let's say, 10 tokens, or you can do it per second. So it's constantly moving, constantly everyone is receiving something. Okay, this one is still thinking. Let me check the automation I ran. So yeah, as you can see, it understood Superfluid. It understood to use Superfluid subgraphs, and it went and queried the data. And I'm not going to go too much into the information right now, but you can imagine, again, for your own use cases, for your own life, you can set up automations that run every morning, every weekend. This is something to quickly trigger. And yeah, with this, it can be Superfluid related. Let's see the visualization it created. Yeah, quite a good one. So this is constant flow. This is GDA. So this is not completely live. Before, I quickly also, just in case, asked to do a few things. And I let it create an interface for creating distribution pools. Just an example, but like told the AI, and again with the skill, it figured out what it has to use, what do the APIs look like, and kind of how GDAs work, and it kind of came up with this very nice interface. But I told it it's for demo purposes. But yeah, it came up with this. So you're setting up the distribution, you have some configuration you need to do, and yeah, you set who will receive, how much are their proportion, and stuff like that. So this is just, again, demo reasons. This could be an interface, but this is also something that can be completely automated on chain through something like a super app. So a programmable contract with Superfluid hooks, or in any other way. But yeah, it's quite cool that it can build something like this. Yeah, also asked it to do a quick interface for wrapping tokens. So it kind of looks like this. You take a token. Oops, it's loading. Okay, there's an error. Okay, so it worked previously. Anyway, it quickly generated an interface to essentially work with Superfluid. I don't remember what this was. Okay, I think that's kind of enough. You can also, of course, work with this from the command line. So for demo purposes, Cloud Desktop is really good, but when I'm on my computer, when I'm working on the daily basis, I'm generally in the CLI, so in the terminal. And yeah, you can trigger the kind of the Superfluid skill from here. You either type it out, Superfluid, then you know it has loaded it, or you just kind of say something Superfluid related, and it will, again, based on the metadata, understand the context of the question and load the skill. I hope that's enough for the demo. I hope that was
Super cool.
Cool. And yeah, one more thing I just want to say is that this is for Superfluid, but the skills thing and the agents things is so cool that you can really bring in your other kind of things you want AI to do. I've been finding more and more things I can let the AI do from my own life and creating the skills for them. Yeah, quick slide about what you can do is brainstorming. It doesn't have to be just software development. You can brainstorm something. You can ask difficult questions. Yeah, automate common observational tasks using natural language, or create quick demos, or create quick presentations. Yeah, I will get to a bonus. So like I said previously, in the evolution of AI engineering is that I've been very iterative with AI so far, but tonight, just yesterday, when I was kind of finishing the presentation, I was like, let me try out the skill in a more autonomous environment. And with Superfluid, what we have is this explorer for kind of seeing the protocol, what's happening from a bird's eye view perspective. And what I did is I told the AI to quickly analyze what is possible here. And then I told it to run overnight and implement basically everything using the skill and using better, let's say, more modern patterns, and let it run overnight. And the whole input from me was like maybe 1 or 2 hours. So maybe 30 minutes to kind of set up the input document for the AI. And then I just let it run overnight. I just told the Claude Code to run till you finish and fire up sub agents to implement it. And what it came up with is this application. So it essentially rewrote the whole thing using the skill. It's not perfect. It has some issues, but it's pretty darn good. So you can, this whole application, let's say 1 or 2 hours to work with. So in the morning, I kind of went over some of the things that were a bit wonky here. But what it demonstrates is just the power of these agents. And also when it has access to good knowledge base, it has access to good information, relevant information, it can perform very well and very autonomously. Yeah. So that's about it. First of all, thanks for listening. I'm very grateful to present to you guys. I hope you learned something. I hope something resonated with you. I will be sending out like an email with more details where to go next. So you don't have to memorize everything from here, but I want to send out a little bit of like a summary, how to contact me if you want to ask something. Yeah. Thank you.
Thank you, Kaspar. Like amazing presentation. I think everybody agrees with me. I have a question for you though. Did you build the presentation using Superfluid Skill? because you said it can be used for that as well. And you said you were working yesterday on it. So did you use Superfluid Skill?
I did. Well, I mean, let's say I used AI. So yes, I had a joke for this, is that no human suffered creating this PowerPoint presentation. Yeah, just worked with Claude and iterating it. So with AI, it's really important. You don't want it to be like AI slop. You don't want it to just generate something and not look over it. You just iterate with it. So this is the presentation that was fully iterated on.
Oh, nice. I think this was very interesting to me. Thank you so much for putting in the work. This has been amazing. I will ask. So anybody has a question for Casper? Okay. There seems to be no questions because I don't see any hands raised. I will share the recording with everybody who's been on the call. All the info that you want to send Casper, let me know, and I can also share to everybody who joined. Insightful session. I really enjoyed it. And will try out Superfluid Skill myself. If there are any questions past the session and that has not been asked here, I will share it with you. To share context on Casper, he's also going to be a mentor in the Good Builders round 3. So a really good contact to have. If there are no questions, I'd just like to say again, thank you so much, Casper. And do share all the information, the links that are required, so I can share with everybody who joined and everybody who intended to join but didn't manage to. This was awesome. Thank you very much. And thank you so much for putting in the work and taking us through everything.
My pleasure. Thank you all, and good luck with the Good Builders season.
Thank you so much. See you all very soon, and I'll share the documents as soon as they're available. Thank you so much for joining. I'll remain for any questions, but otherwise you can leave the call if this is what you would want, unless you have a question. I'll be ending the call in like a minute. Bye, everybody. Thank you for joining. Of course. Okay. Since some people are leaving, some people didn't. Thank you, Casper, and see you. Bye-bye. Chat soon.